Of course, there are various other components in the form of Ethernet switch, power distribution units, InfiniBand switches, and the corresponding cables. Now, you know the servers are Sun servers, Oracle Sun servers. And on each server, you know what software is being installed, right? So this diagram summarizes the architecture, okay, and what software is being installed on every server inside the database machine. So it is pretty much the same compared to your rack implementation, right? So if you know the concepts of rack, how to install rack, how to manage a rack, so you probably know 60–70% of Exadata also. So that way it is same as your standard rack installation and management. So on the database servers, you have grid the operating system. It could be either Oracle Linux or Oracle Solaris, and you install grid infrastructure binaries and database binaries. And you may install single instance database or rack database or a combination of both. So that way, from database server perspective, these nodes are same as your standard nodes in the rack configuration. When it comes to storage server, each storage server has Linux, Oracle Linux as the operating system. And apart from Oracle Linux, Oracle will install Exadata storage server. So this storage server manages the storage devices attached to each storage server. And you know, Exadata uses two types of storage. One is the traditional hard disk based storage. Second is flash disk based storage. So whatever may be the storage device, the storage devices are managed by Exadata storage server. And the Exadata storage server communicates with the database server, right? We know all the software components in this diagram. The only new thing for us is Exadata storage server. So today we will start learning Exadata storage server concepts, the administration, the configuration, okay, and the monitoring, everything related to the Exadata storage server. So once you know this component thoroughly, you should be able to fully manage your database machine environments. Yeah, not each disk funny. The question is from funny, each disk is called as a cell. Okay, it's not the disk. Each storage server is also called as a cell. Cell is nothing but Exadata storage server. So let us understand Exadata storage server now. First, we will have the conceptual understanding of the Exadata storage server. Then we will go to administration part of the Exadata storage server, maybe in tomorrow's class. So today we will see the conceptual understanding. Now, as I told you, Exadata storage server is developed by Oracle and used on Exadata. Instead of using the general purpose storage servers available in the market, Oracle has built their own storage server. And Oracle has included many features in the storage server which are not found in your general purpose storage servers. All these features, okay, improve your database I/O performance and thus contribute to the overall performance of the system. And this is a small piece of software, as I told you earlier. Its size is around 800 to 900 MB, less than 1 GB. And it is added to the system as an RPM, okay, as an RPM, as a package, okay. So you can download this storage server RPM, the package, from Oracle eDelivery website, okay. Now, you know, the different thing in Exadata is the software is installed and configured by Oracle. So when customer purchases Exadata, Oracle ships the hardware to customer site with only operating system installed. Then once the hardware arrives at the customer site, Oracle team will do the initial software installation and configuration. Of course, that is not compulsory to involve Oracle for software installation and configuration. If your team is capable of doing Exadata installation and configuration, you can also do that, okay. But invariably, almost 100% customers involve Oracle for that, because most of the time the local team may not be aware of Exadata, okay. So because installation and configuration is one of the very important tasks. If you make any mistake during installation configuration stage, it will have long-term repercussions, right? So that's why generally every customer involves Oracle for initial installation and configuration. And once the installation and configuration is done by Oracle team, then the day-to-day management is done by the local team. The box will be handed over to the local team, local DBA, or if local DBA is not familiar with Exadata management, customers choose Oracle support, okay. So in that case, Oracle team will support the Exadata boxes, maybe for 1 year or 2 year or 3 year based on the support contract. But ultimately one day your turn will come, so you need to know how to manage Exadata, okay. So now that way the software is installed by Oracle team, and after installation, Exadata storage server has some built-in accounts which are created during the initial installation stage itself. So first we will understand Exadata storage server built-in accounts. Basically, there are two built-in accounts. One is called cell admin, second is called cell monitor. So as I told you earlier, Exadata storage server is also called as cell, okay. So each cell will have two accounts, built-in accounts, cell admin and cell monitor. So these are built-in accounts used to administer and monitor cells. And apart from these two built-in accounts, on each storage server we have root account as part of the Linux. Root account also used to manage cells, okay. Certain activities can be done only with the root privileges. So that way, in total, you use 3 accounts on each cell to manage the cell. So let us understand what is the difference between these 3 accounts and what can you do with each account. First, we'll see cell admin account. This is the main account. As the name suggests, this account allows you to do all the administration activities on the cell. Okay? Like cell has many objects, and before that, to manage the cell, there is a utility, inbuilt utility called cell client. Okay? So you use a cell client utility to manage the cell. Almost every cell command has cell client utility. Every cell command is executed in cell client utility. And like database has objects in the form of tables, views, sequences, synonyms, table spaces, like that, right? Cell also has objects concept. Cell also has different objects. For example, cell itself is an object. Okay? LUN is an object. Physical disk is an object. Cell disk is an object. Grid disk is an object. IORM plan is an object. So, cell has its own objects. You can create objects, you can alter objects, you can drop objects. Okay? You can list objects, you can describe objects. So, all these things can be done as cell admin user. Creating, altering, dropping objects. Okay? Not only that, cell uses ADR/CI, okay, to manage the diagnostic data. So we are familiar with ADR/CI, okay, on the database servers. Cell also uses ADR and it also has ADR/CI utility. So if you want to package any incident related files to Oracle support, you use ADR/CI, right? So you can use the cell admin account and package incidents that can be uploaded to Oracle support. So these are the activities that you can do with the cell admin. Next, you have cell monitor account. As the name suggests, this is used for monitoring purpose only. Okay, and you cannot do administration. Okay, for example, you cannot create, you cannot drop, you cannot alter objects with the cell monitor. You can run few commands only. Like you can see each object information. You can describe each object. Okay, so just for monitoring purpose. Then you have the Linux account, the root account as the standard account. And with root account, you do manage some cell configuration files. Each cell has some configuration files in the form of cell init.vara, cell ip.vara. Okay, so whenever you want to edit the cell configuration, that should be done as root user. And whenever you want to change the network settings related to cell, that should be done as root user. And not only this, during initial software installation and configuration stage, Oracle will load many utilities, many tools on every cell. These tools are loaded under a standard directory called apt oracle.support tools. All these tools requires root access to run. Okay. Then again, there is another command called calibrate. Calibrate will calibrate your hard disks, okay, and checks the performance of each storage device attached to the cell. So sometimes you may feel one of the disk is underperforming. Okay, So you can run calibrate command on that disk, and that way you will know whether the performance of the disk is normal or okay, or it is having some problem. So that calibrate command can be run only as root user. Okay, so these are some additional tasks that requires root access. Other than this, you can run all cell admin command with root account also. Okay, so that is the accounts related concept. So these are built-in accounts. You don't need to create them. Those are built-in. Okay, and you need. Yeah, any doubt?
Yeah, Murali. So this cell concept is explicitly for the storage servers, right? These accounts is not exist on the database server, right?
Correct.
Okay, thank
It
you.
is only storage server. Now, next is cell has its own processes. Okay, so when you install storage server software and start that services, there are many processes, okay, related to the cell. Basically, not many actually, only 3 processes. Each cell at OS level has 3 main processes. As we saw earlier, cell serve is one of the process. MS, management server, is another process. RS, restart server, is another process. Like every database server has many processes at OS level, right? Like a database writer, log writer, okay, SMON, PMON. Each cell has processes at OS level, but cell has only 3 processes: cell serve, MS, and RS. So let us understand okay, about these processes. Cell serve. Cell serve is the main process, okay, and it provides all the storage related services. Every request related to storage is managed by cell serve. It is the main process, okay, and it is a multi-threaded it is implemented as a multi-threaded server. It will have many okay threads when it is running. Then it communicates with the database server to serve the blocks or smart scan requests, only the matching data. By now we know Exadata storage server can serve the entire block or a part of the block, okay, as part of the smart scan. So with the smart scan, storage server can serve a part of the block instead of sending the entire block. Then cell server also implements IORM plans. So there is a concept called IORM, IO resource management, and when we implement IORM plans, all these plans are managed and controlled and implemented by cell server background process. And cell server collects various statistics related to its operation. The DMA, database machine administrator, or the storage administrator, can look at these statistics to understand the performance of the cell server and in general the storage server. Like database has statistics, right? Inbuilt statistics, many statistics. Similarly, cell has many statistics. So cell server collects various statistics related to its operation. Then next process is management server. And as the name suggests, it provides cell management functionality. Okay, cell management under configuration services. It coordinates with the cell client. Okay, and it is also responsible for sending alerts, each cell has inbuilt alert mechanism. When when a fault occurs in the storage server, it automatically generates an alert, and the alert can be propagated to an SNMP based tool like OEM, or the alert can be propagated to email clients directly. Okay, so that you will receive that alert in the form of an email. So MS is responsible for managing and sending the alerts. And like cell serve, MS also collects statistics related to its operation. So you can query these statistics to understand the performance of the storage server. Okay, so at a later stage, we will see all these things. Then the next process is RS, restart server. So as the name suggests, RS is responsible for startup and shutdown of cell server and MS server, MS process. So if they fail, if they stop functioning, the RS will try to restart them without user intervention. If it cannot restart, then DMA intervention is required. Okay, so that is the functionality of the RS server. And when the storage server is rebooted or restarted, all these processes will automatically start. So these three processes, startup and shutdown, is automated as part of the server reboot. You can also manually stop them individually or as a whole, but you don't need to generally do that, okay, unless there is some problem with one of the process. Now, once you log into the cell server, you can check whether these three processes are running or not with the OS command. Okay, so there is a daemon cell-d for all these processes implemented at OS level. Okay, you can use the service command to check the status. Okay, so let me show you. I will stop here and switch to the system so that we can parallelly see theory as well as the demo on that. First, let me show you the VPN client connection, how to access the server and all that. I am sure you know already, but let me show you step by step. So once after installing the VPN client on your laptop or desktop, in the tray you will get this icon, okay, CRSSL client, okay, Cyberam SSL VPN client. So right click on this and click on login. And here you need to provide your VPN credentials, which I shared with all of you. In my case, my VPN is, I am typing my VPN credentials. It may take a few seconds, and now you see this client now connected message, and you will get an VPN IP. So now your system is part of our network. That means you can access the assigned server, okay, using the regular tools like Putty or VNC or any other this thing. Okay, so now I am sure everybody has Putty on your laptop. If not, you can download from my website that drive. So I have Putty. Suppose now I want to connect it to my server. Each one of you are assigned to different servers. So you use your IPs. Okay. For example, now I will connect it to one of these servers. Maybe I will connect it to Sai servers only 130. I don't have any server. I can connect it to one of your server. So type your server IP in the Putty. Say open. Okay. Now login, I shared the login details, and you have access to even root also. Okay, and the standard password in our lab is Euclid123. Wherever password is required, blindly type Euclid123 on the systems. Okay. Now let me tell you one thing here. You can connect it to only database servers. Okay. Not the storage servers. Storage servers can be accessed only from database servers. Okay. That is how I set up the lab. Now I logged into the first database server. In fact, you have access to 2 database servers. But the second database server was intentionally shut down to save the system resources. Okay. Only the first database server is up and running. We start the second database server as and when required during the practices. For most of the practices, you need only the first database server. Okay. So that's why only the first database server is up and running. Now,
Sir, I have one question here.
who is this?
Natraj.
Yeah, Natraj.
So here we are connecting to database server, but in case if I want to connect to OS, a Linux server. As you said, the Linux servers can be accessed by connecting to database servers. So is it possible to directly connect to Linux server?
No. First of all, let me correct you here. All the servers are Linux servers only. Database servers, storage servers are Linux based only. So you should use the correct term storage server. Maybe your intention is you want to connect to storage server?
Yes.
Okay, that is what I am telling. Storage servers can be accessed only from the database servers. You cannot directly connect to storage servers.
Okay, fine, sir.
Yeah, so now I logged into database server. Okay, and these server names are named as, I named them as QR01DB0. Suppose you type host name, right? QR01DB01. So DB01, QR01 is the prefix for the servers. So every server name starts with QR01, quarter rack 01. Okay, you can give any prefix, but I assigned QR01. And the database servers are named as DB01, DB02, like that. Okay. And my domain is, I used example.com domain. Okay. So going by this convention, what would be the name of the second database server? It would be
DB02.
Yeah, QR01 DB02 dot example.com. Similarly, cells are QR01 cell 01. QR01 cell 02.
I think somebody.
Can you be on mute? Yeah, thank you. So cells are named as QR01 cell 01, QR01 cell 02, QR01 cell 03. So like that, there is some convention followed in the lab, right? So if you want to see all the names, once you log into database server, you cat your etc host file better. Every system name is in etc host file. Okay. Now, the first set is the first database server details. This is because this is a standard rack implementation. You will have your public IP, private IP, VIP, and the corresponding names, right? Then the second set is QR01 DB02. So the second database server details. Next to that you have scan IP, because this is a rack implementation, scan will be there. Now the last 3 lines, if you see, related to cells. Okay, so the first cell IP is 10. Okay, cell IPs are in different subnets, whereas database IPs are in different subnets, right? So the first cell IP is 10.0.0.100. Second cell IP is 101, 102. Names are QR01, cell01, short names. Okay, QR01, cell02, QR01, cell03. Okay, so that way you know the names of every database server and storage servers and the corresponding IPs also. Once you do this, first make sure from your database server you can ping to all the other servers. Suppose when I try to ping, okay, to my second database server, will it ping? So second database server name is QR01 DB02. It cannot ping because, as I told you, I have intentionally shut down the second database server. Okay, so this is normal, don't be bothered about this. Now let us ping to each cell. Okay, ping QR01 cell 01. It's pinging now. So from database server you should be able to ping to storage servers. Then the second storage server, pinging. Third storage server, pinging. So this is what you need to do. Once you complete your VPN installation, log into your database server and check if you can ping to every storage server from the database server. Next, let us log into every storage server. Okay, or before logging into the storage server, let us explore the database server. As I told you, I have implemented a 2-node rack setup. So if you are familiar with rack, okay, so it is very easy for you to check what is there on this system. First, let us see what instances are there on this database server. You can use standard grep sman pman command. Okay, now you can see ASM instance is running. For some reason, the database instance is not running on this server, but normally database instance also should be running. Okay, if it is not running, probably if you know rack, you know how to start database instance. Start, and the database name is DBM. That is the name given to the database, and the setup is same on every machine. Okay, you will see the same setup on every machine. Okay, so the database name is DBM. So that means the instance names will be DBM1, DBM2. Okay, so let me try to start this database. I don't know why it was shut down. This is a standard command we use in rack to start the database, right? Okay, looks like there is some problem with this database on this server. Anyway, I don't need database for now. I will check this after the class to save the time. Okay, ignore this. If database is not running, don't worry for now. So Now on the database server, I have installed Grid infrastructure software as well as Oracle software, and I have done separate installation. For Grid, I used an ID called Grid. Okay, so to manage ASM instance, you need to log in as Grid. Then Oracle is installed under a separate account called Oracle. Okay, so based on what you want to do, suppose I want to connect to ASM instance, log in as Grid. Okay, and make sure your environment is properly set. Okay, I think on every machine environment is already set, like Oracle SID, Oracle Base, Oracle Home. Okay, so Oracle SID should be set to ASM instance name. So once this is done, you can connect it to ASM instance with sysASM privilege. Okay, now you are connected to ASM instance. Say you want to see disk group names and their state. So on every machine, I created 4 disk groups. The entire storage is divided into 4 disk groups at ASM level. Okay, so this is what you should see. Data reco, these are standard. And on Exadata, you will have another disk group called DBFS. Okay, so these 3 you will find on the real Exadata server also, the same. Okay, then in the lab I created an additional disk group called GIDG. Okay, so GIDG is used to store your OCR and voting files and ASM SP file. Okay, and the data under echo is for your database. So that is how you can connect it to the ASM instance. So if you want to connect it to database instance, you need to log in as Oracle and make sure your environment is properly set before proceeding. Okay, and then you can connect it to database using this command. Of course, on this node, database instance is not running, right? That is the thing. Then now let us see how to connect to storage servers. From database servers, you can SSH to the storage servers, right? So let us do that. SSH, because we added the storage server details to etc host file, you can simply say qr0 cell 01. I am connecting to the first cell, and I am connecting to the cell as root user only. So the root user password on the cell Euclid 123. Okay, now you logged into the cell. Okay, now you are on the cell, logged in as root user. Exit, you are back to database server. Now this time we will log in, we will SSH to cell with the cell admin account. You know, each cell has cell admin account. Okay, cell admin password Euclid 123. Okay, so now you logged in as cell admin. Exit, back to database server. This time we will log in, we will SSH to cell with the cell monitor account. Again password Euclid 123. Okay. Okay. So you logged in as cell monitor account. So that way, from database servers using SSH, you can log into the operating system of the cell. And during login, you can log in as root user, cell admin user, or cell monitor user. On the real box, in the real environment, your access may be controlled. You may not have root access, you may not have cell admin access. Depending on the role separation, you may have some restrictions on this. In the lab, you can log in. Similarly, you can log into any cell, all the 3 cells. Okay. Suppose I want to SSH to cell 2 as a root user. Okay. So first time when you log in, it will ask you this kind of confirmation. Say yes, then password Euclid123. So now I logged into cell 2. Okay. Similarly, I can log into cell 3 as root user. First time, accept this and password. Now host name is cell 3. Right? So this is what you need to check once you install VPN. These are the basic checks that you need to do. Okay? Once this is done, then you can start your practices. Now I am on cell 3. Any cell is fine for me to show you these commands. This is what we are discussing now. On the cell, you have 3 accounts. We have already verified them. We logged in with all these accounts. Then each cell has many processes, 3 processes basically, which are run as multi-threaded processes. And at OS level, you can grep them. Okay. Similarly, you can grep MS, you can grep RS, right? So you can verify each process. They are running as multi-threaded processes. Then at OS level, these processes are implemented as daemons. You can check whether these 3 processes, 3 daemons are running or not. Service, cell-d, status. It will show you all these 3 processes status, whether they are running or not. So at all times, all these 3 processes status should be shown as running. Okay. If they are not running, that means there is some problem. You may have to check why it is not running and restart them. Okay. So this is where we stopped the discussion. Now, there is another way to start to check the status of each process. Okay. Now I told you, once you are on the cell, you use cell CLI utility to manage the cell, right? So to start the cell CLI utility, all that you need to do is simply type cell CLI. Okay. So now you are at the cell CLI prompt, where you can execute all the cell related commands. Okay. Now there is a command list cell. It will show you the status of the cell. This cell is online. Okay. Slight different command in detail. List cell detail. This will show you more details about the cell. Cell name. Okay. And each cell has various attributes, and it will show you all these attributes under their current values. And if you observe the last 3 lines, okay, they are your cell processes, cell serve, MS and RS. Okay. And in the lab environment, one interesting thing to note is make model. It is showing you as fake hardware. Okay, because we are not using the real Exadata hardware. If you use real Exadata hardware, it looks like this. This is taken on a real box. Make model will be shown as Oracle Corporation Sunfire, that server model actually. Okay. In the lab, we are not using real hardware. That's why in the lab it will show you fake hardware. Okay. So this way you can see whether these three processes are running or not. Okay. Then next thing is every cell has log files. In fact, these three processes, right, has log files. So in case there is some problem, you need to refer to the log files. So what are those log files? Cell has alert log file like database, right? Database instance has alert log file. Similarly, every cell has alert log file. And this alert log file is written by cell serve process. Okay? Cell serve process. And it contains important information about the cell and the runtime messages related to the cell. So for all issues, when you are troubleshooting, the first file that you need to refer is the alert log file of the cell. Then not only cell serve writes to alert log file, RS related messages also written to alert log file. RS doesn't have a separate log file. So any messages related to RS are also recorded in alert log file. Then next file is MS. Okay, you have MS process, management server. Management server has two log files. One is in the form of log file, another is in the form of trace file. So these are the names: ms-odl.log, ms-odl.trace. And written by MS process. Log file contains normal day-to-day operational messages. Trace file, as the name suggests, contains detailed runtime trace level information. Okay, more detailed information. And these three files are auto managed by the cell, auto rotated, so that they will not grow bigger in size and consume the file system. Like on the database, the diagnostic files are auto rotated and auto managed, right? Similarly, all these three files are auto rotated and auto managed by the cell. And where can you find these files? This is not mentioned in the slide. On the cell, okay, you can go to, once you are on the cell, you can go to where log Oracle directory. Okay, so here you have diag. One minute, sorry. Yeah. So this is the standard location, where log Oracle. Under that, the directory structure is diag asm cell, the cell name. Under that, you will see standard diag directory structure: alert, cdump, hm, incident. Okay, then trace. Now, if you go to trace directory, right? This directory structure is your standard ADR directory structure. So trace contains the trace files and the text version of the alert log file. So here ls, so you have the alert log file. Okay, ls ms star ms odl.log. There is no trace file generated so far. Okay, or let me see. These are okay other trace files. So that way you can see the location of these files. Okay, one second. Or actually this is a link to another directory. On every cell, the cell software is installed under opt-oracle directory. Okay, on RealBox also this is the standard opt-oracle directory. Here you will find okay cell, okay, and the cell software version, the platform, okay, release date and all that. And you will find another directory which is linked to this only. Okay, now once you are under cell directory, you can go to log directory. Again you will find the same directory structure, deploy and diag. So go to diag, go to ASM, then go to cell, then go to cell name QR0 cell 03, then you will find that directory structure. So that way or this way, both lead you to the same directory structure. So you can go to trace and say alert, you will find alert log file. Okay, so either this route or this route, both are same, both will lead you to the same directory structure. Clear? Okay, next, cell utilities. As I told you earlier, basically there are two utilities to manage every cell. Okay, they are in the form of cell client, which we saw earlier, and there is one more utility called dclient. Okay, so these two are the utilities to manage the cells, cell client and dclient. The difference is cell client is used to manage a single cell. Dclient is used to manage multiple cells centrally. Okay, and to use dclient utility, you need to do some initial configuration, which we will do in the lab also. Okay, so but other than that, cell client utility is there, and you don't need to do any configuration for using cell client utility. So let us talk about these two utilities and understand more about these two utilities. Cell client stands for Cell Control Command Line Interface, used to manage Exadata storage server. Cell client is installed on each cell. Can be used to manage individual cells only. It works in conjunction with MS to perform administration tasks. And the cell client can be used to do everything related to cell in general, right? Specifically, you can start to stop the cell. You can manage the cell configuration information. You can enable, disable the cells, okay, and manage the objects related to the cell. Okay, so in one word, cell client is the utility to manage a single cell. Then, how to start a cell client utility? We saw already. Once you log into cell, okay, at OS operating system prompt, you can simply type CellClient and you will get a banner and you are in CellClient prompt. You are at a CellClient prompt. And once you are at a CellClient prompt, you need to type the CellClient commands. So this is one way. Another way is, now once you are in CellClient utility at the CellClient prompt, you need to type exit to come out of CellClient. Till that, you can type multiple commands and finally exit. There is another way to start CellClient and execute command. This way, CellClient-e command. So what it does is, it will start CellClient utility, execute this command and exit immediately after that. Okay. So this way or this way. If you want to execute multiple commands, maybe the first method is easy. If you want to execute a single command, this is the method. Okay. Let me show you this. Now I am on the cell, right? How to start a CellClient? Simply type CellClient. Now you are at a CellClient prompt. Now you can type any cell command like a list cell, okay, list cell disk, list okay, grid disk. Okay, so there are many commands which you will learn in this course. Okay, so I typed 3 commands like this. So like this, you can be within the CellClient and execute as many commands as you want. Finally, if you are done, you have to type exit to come out of. Again, you are back to command prompt. Another method is, like if you want to execute a single command, CellClient-e list cell. After E, you type the CellClient command. So what it does, internally, it will invoke CellClient utility, connect and execute this command and shows you the output, immediately exit from the CellClient utility. You are back to OS prompt. Okay. Similarly, CellClient list cell disk. It will list the cell disk and you are back to OS prompt. Right? So these are the 2 methods to execute cell commands. Okay. So we'll stop here for today. And let me show you the hands-ons that you can start now. In the hands-on guide, you can practice this. 1, 2, 3, 4. Okay, 1, 2, 3, 4. So you can easily practice these 4 practices in the lab now. Okay, and I have documented each and every step, the command, the output that you need to execute and observe. Whatever I showed you, they are there in the material, and the material has some additional practices. Okay, like practicing CellClient commands, starting CellClient and practicing CellClient commands, practicing CellClient user accounts related activities. Okay, and observing CellClient related processes. Okay, and probably you can try 5th one also. Just this is to show high availability features of the Exadata. So in this practice, what we will do, we will shut down the storage server, one of the storage server, and okay, we verify that your database is still available for business. So if the storage server fails, there is no impact on the database. Okay, so this hands-on will test that feature. Okay, if you can do it now, otherwise we'll see it tomorrow. Up to 4 you can do comfortably now.